The Valles Caldera is famous to volcanologists and geologists alike, because this is the place where the universal model of caldera formation and development was first devised by Bob Smith and Roy Bailey of the U.S. Geological Survey back in the 1960s. The resurgent dome, like Redondo Peak, is a structural dome. When the caldera forms, it blows a big hole in the ground because you're evacuating 95 cubic miles of pyroclastic flows. And what happens first is that the floor of the caldera collapses and it fills in with some of the pyroclastic material. The magma body is still rising. It's less dense than the surrounding cold country rock. And as it rises, it pushes the floor of the caldera up into the sky. And Redondo Peak is a result of that uplift of continued magma pressure from beneath. One of the beautiful things about Valles is that all the features are so perfectly exposed. You have this symmetrical circular caldera. You have the centralized resurgent dome with a dramatic uplift. You have almost a perfect ring of rhyolite domes that have erupted along the ring fracture zone. And so you can put all this together and create this model. Other calderas, it's not as well expressed.
1.6 million years ago, this giant magma chamber erupted, forming the Toledo caldera. This eruption spewed out 95 cubic miles of ash, molten rock, and superheated gases called pyroclastic flows. The eruption columns formed by the Valles-Toledo eruption rose 20 miles into the atmosphere. Winds spread the ash as far east as the Arkansas River in Kansas and Oklahoma. 400,000 years after the Valles-Toledo eruption, the Valles Caldera eruption occurs in the exact same footprint. Thus, we have two caldera-forming eruptions within 500,000 years, one obliterating most of the evidence of the other.